This is Fenn, President at ITRenew. Very glad to be here with you virtually and again back with the OCP community. So today we're going to be talking about the transformation to a global circular IT hardware industry. And our thesis is that a global circular IT hardware industry maximizes both the financial opportunity associated with IT equipment in the form of TCO and also sustainability. So I've talked in other OCP forums in the past about the financial side of this, which we'll recap briefly later, but today the real focus is particularly on more of a full cost accounting and approach to this, looking at sustainability, looking at decarbonization. So we're going to walk through some new modeling, some recent modeling that ITRenew has done to really look at how do we quantify the full impact from a carbon perspective and sustainability perspective of the hardware that we're all deploying and utilizing at very, very significant scale. And the contention here is if we successfully enable the transformation to a global circular IT hardware industry, which fundamentally depends on open hardware, then we can collectively enable open for all, which of course is a key thesis for the community and for us as a participant. So before we get started, just a little bit on ITRenew. ITRenew is a company that's been around about 20 years. We are in the business of enabling circular data centers. We work across the ecosystem, have deep relationships with major hyperscale partners. We work with them in a variety of services around the safe and secure data decommissioning of equipment and data sanitization and value recovery. And we also have a suite of products and solutions that are the result of that decommissioned equipment, where we transform equipment, proven hyperscale technology, into solutions that are useful, usable, accessible for the broader global markets. We'll talk more about that as we go forward, but that's the context. So stepping back a bit, we're all in this industry together. Everybody seeing this, everybody in the data center industry, in the cloud industry is doing amazing things with the positive potential of the industry. And the sector global tech sector is expanding immensely, right? Infrastructure is expanding immensely. But the question we have to ask ourselves is, at the same time as all the positive potential, are our heads a little bit in the clouds? Because a lot of the infrastructure is out of sight, out of mind now, right? It resides somewhere else. And so this is really a question of, let's look at what the real impact is, and then we can address it, right? So there's some pretty scary stats out there. We're on pace to get to a point in the next 15 or so years where the potential is that our global power consumption in the industry for compute is going to be greater than all the electricity produced in that year. We produce about 50 million tons, excuse me, of e-waste annually, which is an immense amount, right? It's 18-wheel trucks filled up to the top, stacked from New York, front to back, from New York to Bangkok and back, right? The scale is almost incomprehensible. At the same time, we have a context of we're running out of materials, right? We are consuming many more minerals than we can logically support from an environmental perspective. And some are forecasting that within the next 20, 30 years, we're going to have to look to deep sea mining for our minerals for electronic components. And I contend that's the wrong direction to go. We should instead think about how do we curb some of this negative downside, right? The data center, the digital industry collectively is actually kind of going the wrong direction, right? It's on pace to go from about 4% of global greenhouse gas emissions to 8% in the next several years. So we need it, the onus is on us collectively to really think about how do we do all of the positive things we want to do, but also not have an outsized negative consequence for the global stakeholders and for the environment as a whole. Now, we're doing some things really, really well. There's everywhere you look, there's news about companies in the data center industry, large and small, making great gains in renewable energy, right? Which is a very important and essential part of the puzzle here. You see people making significant commitments to get to 100% carbon neutral. You see even recently people committing to get to carbon negative, which includes embodied energy, which is a really important piece of what we're going to talk about. So we need to keep doing this. All of the pursuit for green grids and for advances in PUE and data centers, it's all essential. The question though is it enough, right? And the reality is we can't stop there, because if that's all that we're looking at, then we're just looking at the operational phase energy, right? The efficiency of our data centers, the efficiency and the greenness of our grids, right? But if you look at the whole life cycle of IT equipment, there are bookends on either side of that, right? There's a tremendous amount of energy impact that goes into, you know, mining and manufacturing and assembling all of the systems that ultimately get deployed. So the PreUse phase is everything that happens before a rack in a data center is ever turned on. And then on the other side, there's a post-use phase. So once something leaves a data center, it goes through some sort of an end-of-life process. They vary slightly, but, you know, think about sorting, shredding, smelting of equipment and returning those things through a recycling process. Collectively, those pre and post-use phases are called embodied energy. And we've taken, we've undertaken an exercise recently to try to quantify what is the carbon impact across these phases of use. And looking at that more granularly, think about material sourcing, mining, processing, and so forth, some transportation, then component manufacture across, you know, PCBs, CPUs, DIMMs, hard drives, steel frames for racks, chassis, and so forth. All of those things consume raw materials and energy. And then we run things in a data center, and those consume energy, of course. And then at the end of life, we go through that end of life process. And all the while, we're consuming energy and raw materials, and then we are emitting emissions and waste, right? So these are the system boundaries that we've undertaken in this recent analysis to look at really the impact across those phases. Now, it turns out it really, really matters. So the pre-use phase in a typical, very common setup, which includes mining materials where they are in various parts of the world, manufacturing components in China, and then assembling systems and racks in Eastern Europe, and ultimately deploying them in the Nordics, right? With that kind of a construct, as much as 3/4 of the total CO2 impact is associated with the pre-use phase. So then it's imperative on us, how do we address that, right? And if you enable a circular model, if you enable a second life for equipment, right? So in the linear model, we take things, we make them, and we dispose of them. In the circular model, we take things, and then when the first user is done with them, we find secondary loops of life for them. So in our case, if we could enable a secondary life, that major portion of embodied content goes down a lot, more than 50%, because we're deferring new manufacturing. Now, of course, the operational energy goes up slightly because the equipment is running slightly longer in a data center, but the net impact is about 24% better CO2 impact across the whole system when you move to circular. And to get that same 24% gain, if you tried to do that out of the use phase energy alone, you'd need to get 70% better. So the circular model and looking at really the impact of that embodied content has huge, powerful potential on impact. Now, the obvious next question is, well, what about TCO? Is it cost me more to do this? And the answer quite simply is no. If you make logical assumptions about Moore's law, power, depreciation, you also see the overall system cost come down about 24%. Notably, this is not product level TCO, this is system level TCO, the same system of equipment. Product level, when you compare circular to new or OEM equipment, is even better. So putting it in context, Gartner thinks that there are 46 million servers that are going to come out of data centers with an average of 50 racks or more between 2019 and 2023. If we were to make all of those servers circular, if we were able to give them all a second life, which is a great aspirational goal, we could save more than 30 million metric tons of CO2. And putting that further in context, that's almost 77 million cars annual emissions, right? So this is, we're able, by simply trying to create secondary lives, to have a really significant impact in the absolute. So what does it look like in practice? In our industry, it looks like we start from the very beginning of design. We work with our hyperscale partners. This is ITRenew's business. We work with hyperscale partners to think about how to optimize these multiple loops of life, rather than just do what we've done historically, which is end of life things, sell components, and recycle the rest. So now we facilitate internal reuse pathways. We facilitate racks coming out of data centers to go as rack scale solutions into other data centers, so keeping them in their highest utility value as possible. We remanufacture that same hyperscale technology into other non-rack form factors like edge solutions. And then of course, we recertify components and sell them as well. So we're connecting upstream markets with downstream markets and maximize the lifetimes and the lifetime value of this equipment, right? We're very excited to work with everyone in the OCP community on this because we think collectively, this is how we unlock OCP for all, open for all, right? We take things from hyperscale environments, transform them into the solutions that are relevant for the global markets, and we do that with disruptive TCO. So we're catalyzing all sides of this and enabling other people to take advantage of the full OCP solution and promise that the hyperscalers have had for a number of years now. So just summarizing, I said I'd come back to the financial impact. There's other analysis out there that shows that we have, somewhere between a $50 and $70 billion hyperscale TCO opportunity associated with going circular. So by selling things in the secondary markets as racks and remanufactured edge solutions, we can recover a lot more lifetime value. Same time, we think there's about a $10 billion a year downstream market for these circular solutions, markets that have been blocked previously by expensive economics and proprietary systems and budget constraints. Now, what we talked about today is that when we go circular, we can save about 25% in both net CO2 impact and system level TCO. So this is truly a win-win. And the last thing, thinking about open for all, I want to point out that 52% of the world's population is still not online. And that's a problem for all of us globally. And if we can catalyze very cost-effective equipment into environments that are especially budget constrained, then we can go a long way towards helping bring infrastructure to environments, get people online, and really bring the power of both maximal financial opportunity and maximal sustainability opportunity to everybody. So we're super excited about working with the OCP community on all of this with all of you, and I really appreciate the opportunity to be here today and start to catalyze this motion. Thank you very much.